Hello, dear students. This is Clark sir. So I am back with one beautiful problem in Newton's laws of motion. So have a look. This is a block whose mass is equal to m. This block is hanging with the help of a string and it is in equilibrium, which means net force on this block is equal to what? That's equal to 0. Okay. Now a horizontal force F is applied on this block such that the block deviates by some angle which is given, that's 30 degree. And again the block is in equilibrium, which means again the net force on this block is equal to 0. Okay. Now what we are supposed to calculate? We have to calculate the tension string and the force on the block such that the block is in equilibrium, that is given to us. Let's try to do that. The first thing I will do is that I will see how many forces are there on this block. So in the vertically downward direction, there is a force which is equal to m multiplied by g. All right. Along the length of the string, there is tension string, that is T. Okay. The value of this theta is given, that is equal to 30 degree. And m is also given to us. It is equal to 10 kg. This is given to us. Okay. So tell me what will be the value of this mg then? It will be 10 is 100 Newton, isn't it? Okay. The next step will be that I will try to resolve this t into the rectangular components. So it will have obviously two components, one component in the vertically upward direction, another component in the horizontal direction, exactly like this. Now since this angle is 30 degree, which implies that this angle has to be 30 degree also. Now this t has two rectangular components. This component will be t cos 30, isn't it? And this component will be what? It will be t sin 30 degree. Okay. So there are three forces on this block, and that is, number one is external force, number second is weight, which is 100 Newton, and number third is this tension in the string. The next what I have done is that I have resolved this t in the rectangular components. It has two rectangular components, t sin 30 and t cos 30. Okay. Now what is the net force on this block? The net force on this block is equal to 0, which in turn implies that the upward force, that is this t cos 30, has to be equal to 100 Newton, that is downward force, and the force towards left has to be equal to the force towards right. So let's write down these two equations. So the first equation I will write down here will be t cos 30 degree किसके बराबर होगा? It will be equal to 100 Newton. Now what is the value of this cos 30? Cos 30 is equal to root 3 by 2 is equal to 100 Newton, which implies that tension in the string is equal to 2 into 100 is 200 divided by root 3 Newton. So this comes out to be the tension in the string, which is 200 divided by root 3 Newton. Done with this? Next is that we are supposed to calculate what? We have to calculate the external force. So this is, we have calculated the tension. Now let's try to calculate the external force here. Now see that the force towards right has to be equal to the force towards left. So let's equate those two physical quantities, that is external force F is equal to what? It is t sin 30 degree, isn't it? Put the value of t. What's the value of t? That is 200 divided by root 3 multiplied by sin 30 is 1 by 2. 2 and 2 will cancel. Force comes out to be 100 divided by root 3 Newton. This is the external force applied on the block. This question has been repeatedly asked in JEE mains many a times, so hence becomes an important question in the NLM. See you next time with one more mesmerizing problem in Newton's laws of motion.